Hey everyone, welcome back. Today we're going to look at an introduction to cube roots. If you've seen the intro to square roots video, that'll help you quite a bit today. So 4 cubed brings us to 64. So 4 cubed is 4 times 4 times 4, right? That's what it means. And 64, if we do the cube root, it brings us back to the 4. So the cube root is an inverse to the cube. So let's see here, cube root 64, this is how we write it, a little 3 on top of the radical sign. Cube root of 4 cubed, and this cube root cancels with the cube, like that. And so what's left is 4. So just a couple of cube numbers, 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, 5 cube 125, right? 5 cube is 5 times 5 times 5, right? That gives 125. And so if we cube root 125, it's the same thing as having cube root of 5 cubed. The cubed and the cube root cancel, and what's left is 5. So you can see the inverse here. Cube root 125 gives 5. Cube root 64 gives 4. Cube root 27 gives 3. That's our inverse function here. So a little definition. Let a be a number such that a is greater or equal to 0. We call a to be a perfect cube number if cube root a is a non-negative integer. So some examples of perfect cubes: 0, 1, 8, 27, 64, 125, 216, 343, etc. And that goes on for a long time. Forever, actually. And so 27 is a perfect cube number because if we take the cube root of that, we get 3, which is a non-negative integer. So if you take the cube root of a non-perfect cube, then it'll be what's called an irrational number. That is, a number that cannot be written as a fraction. And so the decimal form of an irrational number is a non-repeating pattern that continues forever. So example, you go and you calculate a cube root 6, 1.817120593, and that thing will go on forever, and there's no repeating pattern at all. So let's practice some algebra. So solve for x. So here we have x cubed equals 27. We want to get rid of the cube, so we do the inverse to both sides, which is cube root. Cancels with the cube, so x equals cube root 27, which is 3, like that. And so it's very similar when we're doing square root, except this time we're doing cube root. So we want to think in terms of cubes when we're canceling or simplifying the radical. And note that there's no plus or minus when we're doing cube root. When we're doing square root, there was, but when we're doing cube root, there is no plus or minus symbol that we're doing. There's only one solution, not two. B. Cube root x equals 4. We want to do the opposite, so we cube both sides to get rid of the cube root. So x equals 4 cubed, which is 64. C. X cubed plus 10 equals 135. We want x cubed on its own, so we get rid of this 10, minus 10 to both sides. X cubed equals 125. We want x on its own, so we cube root both sides to get rid of that x cubed, and x is cube root 125, which gives 5, like that. We can check our answer, right? We plug in 5 into here, so 5 cubed 125 plus 10, it does give 135. We're good to go. D. 3x cubed minus 7 equals 74. We want to get rid of the 7 first, so plus 7 to both sides. 3x cubed equals 81. We want to get rid of this 3 now before cube rooting, so we divide by 3 both sides. X cubed equals 27. Cube root both sides, x equals 3, like that. Practice 1. Solve for x. So we got A, B, C, and D. Go ahead and pause the video and perform those, or just solve for x. Okay, A. Cube root x equals 7. Cube both sides to get rid of the cube root. X equals 343. B. X cubed equals 2197. Cube root both sides. X equals cube root 2197, which is 13. C. X cubed minus 7, 209. Plus 7 to both sides, get x cubed on its own. cube root both sides to get rid of the cube, and so x equals 6. Excuse me. D. 5x cubed plus 13 equals 53. Minus 13 to both sides. 5x cubed equals 40. Divide by 5 on both sides. X cubed equals 8. Cube root both sides to get rid of the cube. X equals cube root 8, which is 2, like that. And it's that easy. I'll see you guys in the next video.